The final object we're going to cover is statistics. The engine behind Redshift, the query engine, the one that takes your largely English language query and turns it into the actual machine code that goes and gets your data, it's a massively complex piece of technology. Really, there's a staggering number of decisions and assumptions and logic that the query engine must take into account when deciding the best way to go get your data. So one of the most critical sources of information that the engine uses to make good decisions are collected statistics. These are objects that gather information about things like row counts, table makeup, past query usage, and many other data points. These statistics are observations made by Redshift. But like any data point, they can drift away from representing what is truly going on with your data. And they can be missing entirely, leaving the Redshift query engine to just make guesses about the best way to go get data. The command that you should know and wield like a pro is the analyze command. This command is your tool for ensuring statistics actively and accurately represent the true makeup of your data. Now you can analyze an entire database, an individual table, or even an individual column. Running analyze does require some resources and overhead, however, so you should be familiar with your own query load and when it makes sense to do this command and do this type of maintenance. Now, there are circumstances where Redshift will create its own statistics, but these statistics are a generalized approach and likely over the long run are not going to be best practice for your specific scenario. A very common practice is to run analyze after data loads, a major data update operation, or anytime there is a significant change to the profile of your data and queries. Now, like the compression analysis that we did, the copy command itself includes a clause called stat_update_on that, if specified, will ensure analyze is run as part of the load. I really like this option because loading data is usually going to be done at a time when some overhead is acceptable, and it can take advantage of this new data immediately to create new statistic profiles. Now, aside from just simply running analyze, you can also set a specific threshold in terms of a percentage of rows changed for when analyze will run. In other words, if statistics exist and it knows that the table has not had a sufficient number of changes to meet the threshold percentage set, then the table will be skipped. The default value for the threshold, unless otherwise specified, is 10%, which sounds pretty good, but consider a table with 1 million rows. It would need at least 100,000 rows modified to meet the threshold where new analysis would take place. It seems to me that the data profile could change pretty drastically without meeting that threshold. For many operations, this might be far too many rows to meet your needs. So, setting a lower analysis threshold might be better. Now, like I mentioned, when analyzing data manually, you can also specify that you only want specific columns analyzed. Another option is to say that you only want predicates in queries to be analyzed. That is done like this with this syntax. What Redshift does with this clause is it will go through and verify columns that have been used in past queries as a predicate, and then it will only analyze those queries. This is all covered quite well in the AWS documentation, so I would follow that link here and get familiar with that subject. The analyze command and its informational system table, STL_analyze, are both commands that you should be comfortable with running if you're administering Redshift, or if performance of Redshift is something that you're interested in or responsible for. Now, here's going to be a little gem of this course. If you would like access to some extremely helpful pre-written analysis, monitoring, and management queries, check out this GitHub link. This is a collection of queries, tools, and utilities put together by the AWS Labs team. Specifically, the one I'm talking about right now is the perf alert utility, a real gem for managing statistics and table analysis related to the vacuum. Now, this GitHub link is completely filled with some awesome little utilities written by the AWS Labs team. They're well documented, so I would definitely say follow this project and download some forks of your own and see how this code is written. You can learn a lot about Redshift by just going through this code. All right, I feel like we've covered a lot of really good information in this one module, but we still have quite a few things to cover. Now we're going to get closer to the actual production of data and talk about queries and reports next. No matter how carefully you've built your cluster, loaded your data, and designed your table objects, a poorly written query will still fail to perform and pretty much nullify all that effort that you've put into it previously.